everyone, welcome to my channel Math 6 IIT Academy. In this video, we are going to discuss about the position of 2 points with respect to a straight line and also the equations of the parallel lines and also perpendicular lines and also the distances between the point to the line and also the distance between the two parallel lines. Okay, so we'll discuss one after one in detail. So first of all, let me discuss about the position of points with respect to a line, or you can say straight line. So here I am taking P x1 comma y1 and Q x2 comma y2, and these are the 2 points, and I am taking a straight line equation, that is ax plus by plus c is equal to 0. So when can we say and how can we say the 2 points are on the same side of the line or different sides or opposite sides of the line? Okay, so here we will see, suppose here this is our straight line ax plus by plus c. Okay, so now here same side means here suppose p and q are here. Okay, and opposite side means here this is the line equation and here let it be p and also q. So in which, or means what is the condition for which the points p and q are on the same side of the straight line and also on the different sides of the straight line. Okay, so that we will see now. So here already we have discussed in our last videos. Suppose here I am taking a line segment P x1 comma y1 and Q x2 comma y2. Okay. Now suppose a straight line, this ax plus by plus c is dividing the line segment PQ in the ratio of lambda is to 1. Then here you can see one common point, let it be r of x comma y. Then what is r here? That we will see now first. So here use the section formula to find out the r value. So here according to the section formula, what we can write? By section formula we can write that lambda into x2 plus x1 divided by lambda plus 1 comma lambda into y2 plus y1 divided by lambda plus 1. Okay, so this is the r, point r. But this r is a common point to the line segment PQ and also the straight line ax plus by plus c is equal to 0. That means here this equation is satisfied by the point. So when you substitute in the equation ax plus by plus c is equal to 0, then so what you will get here? X means what? X coordinate. What is x coordinate means here? Lambda x2 plus x1 divided by lambda plus 1 plus b into y means here lambda y2 plus y1 divided by lambda plus 1 plus c is equal to 0. Okay, so now here take the LCM lambda plus 1, and after taking lambda plus 1 is LCM, here you will get a into lambda x2 plus ax1 plus b into lambda y2 plus dy1 plus c into here lambda plus 1 is equal to 0. Okay, here we are taking the LCM lambda plus 1. Now separate the terms containing lambda and also free from the lambda. So here we are taking lambda is common in this, here ax2 and here you will get by2 and here c. Next, which are free from the lambda, ax1 plus by1 plus c is equal to 0. So take this term into that side, then what you will get here lambda into ax2 plus by2 plus c is equals to minus of ax1 plus by1 plus c. So by this what we can write means here lambda is equal to minus ax1 plus by1 plus c divided by, take this term into the RHS side, then you will get ax2 plus by2 plus c. That means here the point r or the line ax plus by plus c dividing line segment PQ in the ratio of lambda is to 1. So which is equals to minus ax1 plus by1 plus c divided by ax2 plus by2 plus c. Okay, so this is about only the in which ratio the line is dividing the line segment. Okay, so next we will see. So now case 1. So in this case, first you take, let P and Q be the same side. P and Q be the same side of the line. So P and Q be the same side of the line means here what about the diagram means here? This is P and this is Q. And here you can see the common point to the line segment and also the straight line, that is R. So here this R is clearly, it is dividing PQ externally. Okay, R is dividing PQ externally. When it is dividing externally, here what will happen? The ratio is negative. So that means what? Lambda is negative. So lambda value, first of all, let me write. Lambda is equals to what? Minus ax1 plus by1 plus c divided by ax2 plus by2 plus c. This value is negative because R is extended to PQ. So negative means here what? Less than 0. Now here minus symbol is there. So multiply both sides with minus. So when you multiply minus, what will happen means this symbol will be changed. That means here ax1 plus by1 plus c divided by ax2 plus by2 plus c is greater than 0. Okay, that means here this can be written as, this is a linear equation in two variables. So thus if you can write in the form of a function, we can write f of x1 comma y1 divided by f of x2 comma y2, which is greater than 0. Okay, so that means if f of x1 comma y1 divided by f of x2 comma y2 is greater than 0, then the points P and Q are the same side of the line. Okay, so this is about the first case. Now we will see the second case. So second case means here, now take the line, take the points P and Q are on the opposite sides, are on the both sides. Okay, so now here you can see the R. R is now dividing PQ internally. In which ratio it is divided means here lambda. Okay, so now it is dividing internally means here lambda value positive. So lambda value positive means what here? What is lambda? Here lambda means minus ax1 plus by1 plus c divided by ax2 plus by2 plus c. This is the value of lambda. Now this lambda is positive. Positive means what here? Greater than 0. So greater than 0 means what here? Because of the minus symbol, when you multiply here with minus symbol, then you will get ax1 plus by1 plus c divided by ax2 plus by2 plus c is less than 0. So what we can write means here, this is f of x1 comma y1 and f of divided by f of x2 comma y2 is less than 0. So when the 2 points are on the either side of the straight line, then the condition is f of x1 comma y1 by f of x2 comma y2 is less than 0. So the condition for the same side of the line is f of x1 comma y1 by f of x2 comma y2 is greater than 0. Okay, so this is important one. So next concept is position of a point in a triangle. So here position of a point which is inside of a triangle. Position of a point which is inside of a triangle. So here let me take one triangle ABC here like this. ABC. Okay. So now here take the point P which is inside of the triangle, that is x1 comma y1. Let it be. And simply join PA, PB and also PC. And take the vertices as like this, that is x dash comma y dash. Next x double dash comma y double dash. And C we can take it as x triple dash comma y triple dash. Okay. Now, what about the equations of the sides of the triangle? So let BC is equals to a1x plus b1y plus c is equal to 0, and CA is equals to a2x plus b2y plus c2 is equal to 0, and CAB which is equals to a3x plus b3y plus c3 is equal to 0. Okay, so when we have everything, means the sides of the triangle and also vertices of the triangle, and how to find the point P of x comma x1 comma y1, position of the point which is inside of the triangle, means here just now we have completed one concept, that is position of a means the position of a points with reference to or with respect to straight line. So if you clearly observe the diagram with respect to the line BC line is a1x plus b1y plus c1 is equal to 0. So this is a straight line equation. So with respect to this straight line, the points P and A are on the same side of the line. So when it is same side of the line, what will happen here? A1 x1 plus b1 y1 plus c1 divided by a1 x dash plus b1 y dash plus c1, okay, which is greater than 0. Okay, f of x1 comma y1 divided by f of x2 comma y2 is greater than 0 when the points P and Q are on the same side of the line that just now we have seen. So by that I have written, because the point P and A are on the same side of the line segment BC or line BC. So this is greater than 0. And similarly when you observe here, here C and also P, or we can take B and also P better. First when you are taking B and P with the respect to the line AC, with respect to the line AC, P and B are on the same side of the line. So here what is the condition means? Here f of x1 comma y1 divided by f of x2 comma y2 greater than 0. So same condition, but we have to write the points here. They are x1 y1 and x2 y2 we have taken, but here the points are x1 y1 and also x double dash and y double dash. So that only will be changed. So here a1, so here it is a2. The straight line equation AC is a2x plus b2y plus c2. So that a2x1 plus b2y1 plus c2 divided by here points a2 x double dash plus b2y double dash plus c2 is greater than 0. Next here with respect to AB line, P and C are on the same side of the line. So again here with respect to this side of the line AB, what will happen here? A3x1 plus B3y1 plus C3 divided by A3x triple dash plus B3y triple dash plus C3 is greater than 0. Okay. So now the position of the point, position of P of x1 comma y1 is the intersection of all three inequalities. Okay, so here after solving all these three inequalities, we'll get the position of the point x1 comma y1 which is inside of the triangle. Okay, so this is the common procedure, but here we have a shortcut here to find the answer easily. So that also we will discuss, because always solving three inequalities, it takes much time. So we will see that also. So here better, let me take the same diagram here. So in the shortcut method, what we have to do means, first draw the diagram with the given information. Okay, first we have to draw the exact diagram of the given information. Okay, so second, what we have to do means, here we have to take the point or the moving point P of x1 comma y1 on the line y is equals to ax plus b. Okay, so when you are taking this straight line based on the question, so when you are taking this, here what will happen means, here with respect to for every x1, here y is equals to ax plus b. So here p of here x1 and y is equals to y1, we can substitute and we can write here x1 plus b. Okay, so here we have substituted y is equals to x plus b here. Okay, so now here the straight line when you draw, that will intersect the two sides of the triangle at distinct points. So here let me draw the some rough diagram here. Suppose here A, B, C. Okay, so now we are drawing the line y is equals to x plus b. Okay, so this, on this we have the point here p of x comma y1 or x comma y simply. Now this is a straight line which is intersecting the any two sides of the triangle. Let it be this AC and also BC. So just find out this as D and also E. Okay, now we have to solve this equation. So this equation to find the point D, and again this equation and the AC equation to find the E. So here after solving these two equations, suppose we are getting D is alpha comma beta, and after solving these two equations AC and also this y is equals to x plus b equation, we are getting suppose gamma and delta. Okay, then what is x1 means, here it is between alpha and delta, and here y is between beta and delta. Sorry, here x1 is between alpha and gamma, and y is between beta and also delta. So this is useful and also very easy to find the answer in this case. Okay, so to understand this concept, let me give an example to clear the concept. So here for which values of t, the point p of t comma t plus 1 lies inside of triangle ABC, where A is suppose 3 comma 0 and B is minus 2 comma 0 and C is suppose 6 comma 1. Okay, so now for what values of t the point P lies inside of the triangle, that we have to find out. Okay, so first of all, what is our first step means in this? First we have to draw the rough diagram for with the given information. So here what is this are given ABC. So it is very clear that here 3 comma 0 means it is on minus 2 comma 0 3 comma 0. Better here just take 0 comma 3. Okay, So when you are taking here 0 comma 3, here it is on y axis, and here minus 2 comma 0 means it is an x axis, and here both are positive, so 6 comma 1, so you can take on first quadrant, so here it is 6 and this is 1, let it be, so here it is C 6 comma 1. Okay, so here 0 comma 3. Okay, so now simply join this. Okay, so this is the exact diagram of the given question. Okay, so now what we have to do means here you have to select the equation. So here what is given means here p of t comma t plus 1. So let y is equals to x plus 1. Y is equals to x plus 1 I am taking as the equation. Okay, so now here when you are taking that equation and when you are drawing that line that will intersect the two sides, you know, either these sides or these sides, whatever the sides we can draw. So here this you can take as suppose D and this we can take as suppose E. Okay, if you draw anywhere you will get answer, no problem. So here this is straight line and this straight line gives you know, this is what straight line means here, y is equals to x plus 1. Okay, y is equals to x plus 1 means always it is, you know, it gives the with slope is equals to 1 and also y intercept is 1. Okay, y is equals to mx plus c form. So fine. So now D and E. So now we have to solve the equation BC and also this y is equals to x plus 1 and also AC equation and also this y plus 1. Okay, so now here how to find the equation BC first. First let us find the BC equation. So how to find the equation, just now we have yesterday in last video I made how to find the equations. So when we have 2 points, the equation is nothing but here what, y minus y1 is equals to y2 minus y1 divided by x2 minus x1 into x minus x1. Okay, the equation of the straight line which are passing through the 2 points x1 comma y1 and x2 comma y2 is y minus y1 is equals to y2 minus y1 by x2 minus x1 into x minus x1. This we have to remember. So now here y minus y1 means here you can take this 1 is equals to y2. Y2 means here you can take suppose 0 minus y1 means here 1 and x2 means here we have taken this as y1. So fine, this is the what, x2 is equals to minus 2 and x1 is minus 6 and x1 is 6. So now here y minus 1 is equals to minus 1 by minus 8 x minus 6. So here and these two will get cancelled and we will get what here 8. So here 8 into 1 minus 1 is equals to x minus 6. So here x minus 6 is equals to 8 by minus 8. So here x minus 8 y plus 2 is equal to 0. Okay, so this is the BC equation. So BC, let me write here. So BC is equals to what, x minus 8y plus 2 is equal to 0. Okay, so this is about BC. Now we have to find out AC also. So here AC. So here AC means here what, y minus y1. Y minus y1 means here 1 I am taking is equals to y2. Y2 means here 3. Y2 minus y1 divided by x2 minus x1. So here x2 means 0, x1 is 6 and x minus x1. Okay, so now here when you are simplifying here y minus 1 is equals to 3 minus 2 is minus 6 and here it is x minus 6. So here 2 1s are 2 3s are, so here minus 3 into y minus 1 is equals to x minus 6. So here when you are simplifying here x plus 3y minus 6 plus 3 is equal to 0, hence here the equation is x plus 3y minus 3 is equal to 0. Okay, so this is a AC equation. So here x plus 3y minus 3 is equal to 0. Okay, so now we have to solve this y is equals to x plus 1 and also BC first to get D. Okay, so solve here BC is equals to what means here x minus 8y plus 2 is equal to 0. So here x minus. So simply here substitute the value of y here. So here 8 into y means here what? X plus 1 plus 2 is equal to 0. So that means here x minus 8 plus 2 is equal to 0. So that means here minus 7x is equal to what here? Minus 6 becomes plus 6. So here x is equal to what? Minus 6 by 7. Okay, so this is minus 6 by 7. So now substitute this value in this, then you will get y value. So here 1 minus 6 by 7 means here 1 by 7. So now D, point D we can write. Okay, why we solved these two lines means this is the intersection point of the lines. Y is equals to x plus 1 and also BC. So we have solved these two equations. And after solving these two equations, you can find the common solution means intersection point, that is called D. And D is equals to what means here minus 6 by 7 comma plus 1 by 7. Okay. So now similarly we have to find the value of E here. Okay. So now solve y is equals to x plus 1 and also here AC. Okay. So here AC is nothing but here x plus 3y minus 3 is equal to 0. So here x plus 3 into y means here x plus 1 minus 3 is equal to 0. So hence x plus 3x plus 3 minus 3 is equal to 0. So hence 4x is equal to 0. So here x is equal to 0. Okay. So now x is equal to 0. Next here x is equal to 0 means here y is equal to 1. So here 0 comma 1 is a point T. Or you can write here. Okay. So now for what values of theta, for what values of t here they have given. So here t should be which is between minus 6 by 7 and also 0. So that means here it is less than 0 and here greater than minus 6 by 7. Okay. So for all these values, that means here you can write theta which is belongs to minus 6 by 7 comma 0. For all these values of t, this point P which is inside of the triangle. Okay, so this is only shortcut method. Of course, if you solve and direct method, it takes more time than this side. Okay, so hope you all understood. So next we will move on to the next concept. Okay, so now equation of a parallel line. Equation of parallel line. Okay. So first of all, I am taking here ax plus by plus c is equal to 0. This is an equation. Okay, straight line equation. So let a1x plus b1y plus suppose c1 is equal to 0 is parallel to equation number 1. Okay. So then how can we derive the equation of a straight line which is parallel to the equation number 1? So we are supposing that this is the straight line which is parallel to the equation number 1. Next we will derive this and we will get the answer. Okay. So here we will see proof. So here these two lines represent what here? Parallel. So yes, in last video I have given the condition for the parallel lines. So when two lines are parallel, then a1 by a is equals to b1 by b is equals to, you can take some constant. Okay. So now here we can write a1 is equals to a into k and also b1 is equals to b into k. Now substitute these values in the equation number 2. What will we get? a1 means here akx plus b1 means here bky plus c1 is equal to 0. And in this, when you are taking k common, then you will get ax plus by plus c1 by k is equal to 0. Okay, so that means here ax plus by plus, suppose lambda is equal to 0, here lambda is c1 by k, just a constant. So what you have to understand means the equation of a straight line which is parallel to the ax plus by plus c is equal to 0 is ax plus by plus lambda is equal to 0. Here there is no change in the x and also y coefficient. There is a change in only the constant term that you have to observe here. Okay. So next here we will see one important point here. You can take it as a note. So the equation of a straight line parallel to ax plus by plus c is equal to 0 and passing through the point p of x1 comma y1. The equation of a straight line which is parallel to ax plus by plus c is equal to 0 and also passing through the point. So here the equation is parallel. So when we want to find out the equation which is parallel to one equation, so here we have to remember about the slopes. So when the equations are parallel, then their slopes are equal. So here slope of the equation is what means here minus a by b. And here they have given a point that is p of x1 comma y1. Now in my last video I have explained different form of the straight lines. So slope and also one point. So point slope form. Okay. So what is the line equation now? Y minus y1 is equals to m into x minus x1 point slope form. Y minus, what is y? Y1 means y1 only. M means here minus a by b and here x minus x1. So now just take this b into this side, then y minus y1 is equals to minus a into x minus x1. When you arrange everything, then you will get here a into x minus x1 plus b into y minus y1 is equal to 0. This is the condition. Okay. So what is this means? The equation of a straight line. This is the equation of a straight line which is parallel to ax plus by plus c is equal to 0 and also which is passing through the point p of x1 comma y1. Okay, so that is this one. So this is about the parallel. Next we will see about the perpendicular. So here perpendicular. Okay, so here perpendicular means right. So first of all I am making a straight line and I am assuming that this is the perpendicular to equation number 1. Okay, this is a straight line and now we have to find a perpendicular line which is perpendicular to this equation. But we are assuming that this is the perpendicular line. Okay, so now we will derive this and after that we will get the equation. Okay, so now we will see the proof of it. So proof here. So here these two lines represent perpendicular lines. So in my last video I have given the condition for the perpendicular lines, that is product of the x coefficient. So that means here a into a1 plus b into b1 is equal to 0. That means what we can write here, a1 is equals to minus b1. So that means here we can write here a1 by b is equals to minus b1 by a. These two are equal. Now suppose that these two is equal to some constant and now express a1 and also b1 in terms of a or b. Okay, so here a1b by b is equals to k. That means here a1 is equals to bk minus b1 by a is equals to k means here b1 is equals to minus ak. Now these values you have to substitute in the equation number 2. From 2 implies, so here a1 means here bk x, b1 sorry a1 means here bk, next b1 means here minus aky plus c1 is equal to 0. Now take k common, then you will get bx minus ay plus c1 by k is equal to 0. Okay, so now bx minus ay, let it be some lambda here. So bx minus ay plus lambda is equal to 0 is what? This is the line equation which is perpendicular to the equation ax plus by plus c is equal to 0. Okay, so once if you observe this, here y coefficient is b and here x coefficient is b, and here x coefficient is a, here y coefficient is a, and here y coefficient have negative sign and here y coefficient have a positive sign. Okay, and of course the constants are also different. Okay, so just understand the differences between the equations. So hence we can remember easily the equation which is perpendicular or parallel to the straight line equation ax plus by plus c is equal to 0. Okay, so now here we have again note, right? So now the equation of a straight line which is perpendicular to the ax plus by plus c is equal to 0, and also which is passing through the point here p of x1 comma y1 we have to find out. Okay, so let me write clearly here the equation of a line. Simply I will write perpendicular to ax plus by plus c is equal to 0 and passing through p of x1 comma y1 is what? Okay, so here the equation of the line perpendicular to this. So perpendicular to this means here, so here in last video I have discussed one thing. When two lines are perpendicular, their slopes are what? Product of their slopes are is equals to minus 1. So now here what is the slope of this equation means here minus a by b, and let it be suppose m1 or m is the slope of the next equation, means perpendicular line equation slope is m, then which is equals to what? Minus 1. Product of the slope is equals to minus 1. So now this minus and minus will get cancelled and you will get m is equals to what? Here b by a, and now the point is what? Here p of x1 comma y1. Now we can find the equation because we have slope and also the line. So point slope formula again we can use and we can find out the line equation. So how can we find? Means here y minus y1 is equals to m. M means here what? Here b by a into x minus x1. So here when you arrange everything here you will get a into y minus y1 minus b into x minus x1 is equal to 0. Or else you can write here into the RHS side you can write bx minus x1 minus a into x y minus y1. Okay, so anything is same. So this is the equation. This is the equation of a straight line which is perpendicular to ax plus by plus c is equal to 0 and which is passing through the points x1 comma y1. Okay, so this is about the perpendicularity. Okay, so next. Next here, distance of a point from a line. Distance of a point from a line is our next concept. Okay, so here let me take the general equation of the normal equation for the straight line is ax plus by plus c is equal to 0. So here when you arrange everything according to the intercept form, then here we can write x by minus c by a plus y by minus c by b is equals to 1. Okay, when you draw the graph of this, it is very simple to identify. Means to draw the graph of the straight line. So this is the straight line which represent of course ax plus by plus c is equal to 0 only, and with x intercept minus c by a. So here a minus c by a comma 0, and this is b, we can write 0 comma minus c by b. Okay, of course everything we will take in first quadrant only.
here no need to confuse about here minus c by a, here it is indicating that negative value. So yes, if when c is negative, then this becomes positive. So whatever the coordinate we are taking, there is no problem at all. Okay. So now we are taking a point P. So let it be suppose x1 comma y1. Now distance of a point from a line. So what is the distance between the point to the straight line, that we have to find. So draw the perpendicular from the point P to the line, let it be suppose M, and simply join B, P and also AB. Okay. So here when you observe in triangle APB, when you observe the triangle APB, here three vertices are known to us. We know three vertices, so we can find the area easily. So area of triangle APB is equal to what here, 1 by 2 into, I am using the stair method. So stair method means here we have to write all the vertices. So first let me write here this B. So 0 minus C by B, here x1 comma y1, and here minus C by A comma 0, and we have to conclude with the first point. Okay. So next here, which is equal to what, 1 by 2 into modulus of, first multiply here 0 into y1 0 and x1 into 0 0, and here minus into minus plus c into c squared by ab minus into here x1 into minus c by b, so minus c by b into x1, and again minus c y1 by a. Next here we get 0, so we can close. So which is equal to what, 1 by 2 into, here when you are taking LCM here, LCM is AB here. Okay. So when you are taking LCM here, what we have means here we have c square minus into minus becomes plus, here c a x1 plus here c b y1. Okay. So when you are taking c common, then you will get here mod c divided by mod ab. Okay. So you will get here a x1, after taking c common, here we have ax1, and after taking c common, here we have d by 1, and here we have c square, one more c is there. So this is the thing. So now you can take this is first equation, and again here here we can find the AB length. We can find the AB length by using the distance formula. And actually what we have to find out means we have to find the distance between the point to the straight line. Straight line means here perpendicular to the AB, perpendicular line to the AB which is passing through the point P. So PM we have to find out. So PM which is not covered in this. Okay. So how to find PM means here, what we have to do means here again we have to use the same triangle APB and use the normal formula to find the area of the triangle, that is 1 by 2 into base into height, and equate them, then you will get the condition. So area of triangle APB is 1 by 2 into base. Base means I am taking AB into height. Height is PM, that only we want. Okay. So now find out AB and write down and just equate these two equations and you will get the PM, means the distance of the point of a point from the straight line. Okay. So that you will get. So here which is equals to what, 1 by 2 into AB means here square root of x2 minus x1 whole square, that means here c square by a square, and the plus here 0 and also c minus c by b is there, so here c square by b squared into PM. So you can take it as equals to 2. Now what we have to do means here we have to equate first 1 and also 2, then you will get the PM after simplification. So here let me erase this. Right. So now when you are equating 1 by 2 into mod C divided by mod AB, modulus of ax1 plus b by 1 plus c is equals to what, 1 by 2 into c square root of this c square plus, here better I am taking the LCM here. LCM is a square b square. So here c square I am taking common, hence a square plus b square by a square b square into pm. Okay. So now here both side 1 by 2 will get cancelled, and here mod c divided by mod ab into modulus of ax1 plus by1 plus c is equals to, here c square when you are taking out, then you will get what here mod c, and divided by mod ab also will come out, because here square root is there and here square terms are there. So here square root of what is the remaining term means here square root of a square plus b square into pm. So now here both sides we can cancel this. So hence pm. So what you get here, pm is equals to what? pm is equals to, take this term into that side, then you get pm. So here modulus of ax1 plus by1 plus c divided by square root of a square plus b square. Okay, so this is the pm. Okay, so the distance of a point from a line is modulus of ax1 plus by1 plus c divided by square root of a square plus b square. Okay, so of course this is important. So I hope you cleared about the proof. Okay, right. So next we will see another concept which is related to this. So here so with this concept what we have understood means here the distance from a point to the straight line ax plus by plus c is equal to 0 is modulus of ax1 plus by1 plus c divided by square root of a square plus b square, means here sum of the squares of the x and also y coefficient. Okay, so that we have observed. Now here distance between the two parallel lines. Okay, distance between two parallel lines we will see here. So here I am taking here ax plus by plus c is equal to 0. This is the first straight line equation, and let it be another straight line equation which is parallel to this is what? Suppose here a1x plus b1y plus c1 is equal to 0, and here take it as 2, and here 1 and 2 are parallel to each other. Okay, so now how can we find the distance between the parallel lines? Actually, what is the distance between the parallel lines means here, suppose these are the two straight lines, and this straight line is representing here ax plus by plus c is equal to 0. Okay, so now this line is representing a1x plus b1y plus c is equal to c2 is equal to 0, c1 is equal to 0, whatever it may be. Okay, so now distance between the two straight line means here two parallel lines means the perpendicular distance from a point on the straight line to a point on the another straight line. So perpendicular distance only. So first of all I am taking point P, x comma y1, or suppose x1 comma y1 it is there. Let suppose that P is a point on the straight line ax plus by plus c is equal to 0. Okay. So this is a point on the straight line. So that means here the straight line will be satisfied by the point. So hence what we can write means here a x1 plus b y1 plus c is equal to 0. Okay. So now right. So here you can take this as suppose here 3, and now actually parallel line means here x coefficient y coefficient should be same. Okay, so later I will change, no problem if we don't get it. So here now just now we have seen this is a point now. Now the perpendicular distance from a point to the straight line is what here? A1x. A1 x1 plus modulus of b1 by 1 plus c1 divided by square root of a1 square plus b1 square. Okay, so this is the distance. So here actually here yeah, I did a mistake here. Sorry for that. When we have a parallel line, x and y coefficients should be the same, only constants are different. Okay, so that part. So here right. Okay. So first of all, let me explain again. So here ax plus by plus c is equal to 0 is a straight line equation. Next, one more straight line which is parallel to the first straight line is ax plus by plus c1 is equal to 0. Okay, so these two are parallel. So now when you are drawing the diagrams here, so first of all let me take one point B here x1 comma y1 on ax plus by plus c is equal to 0. Okay, so when the point B is lying on this equation, so that means here it is this equation is satisfied by the point. So hence we have about ax1 plus by1 plus c is equal to 0. I am taking this as equation number 3. Now here we can find out one point, and now we can see it is a perpendicular line to the straight line. So just now I have explained that the distance from a point to the straight line is nothing but modulus of ax1 plus by1 plus c1 is divided by square root of a square plus b square. So okay, so same thing I have written here. So here this is the straight line equation, and the distance from the point P of x1 comma y1 to the straight line is modulus of a x1 plus b y1 plus c1 divided by square root of a square plus square root of b square. Okay, so now from equation number 3, from this equation what we can write means here a x1 plus b y1 is equals to, we can write minus c. Okay, so simply when you are replacing here, then what we get here means here modulus of c1 minus c divided by square root of a1 square plus b1 square. Okay, so this is the derivation. So finally what we have to understand means here when we have two parallel lines, ax plus by plus c is equal to 0 and ax plus by plus c1 is equal to 0. What about the distance between these two parallel lines means modulus of c minus c1 or c1 minus c, whatever may be, divided by square root of a square plus b square. Simply you can remember this point in mind. Okay, so this is the derivation and also explanation to get that. Okay, so next we will see another concept. So here one more last concept we have, that is about area of parallelogram. Area of a parallelogram. So here first let me draw the diagram to make it clear to you. So first ABCD is I am taking a parallelogram. So parallelogram means what? Here opposite sides are parallel. Okay, that we know. So here let me take the equations here. AB is equal to what means here a1x plus b1y plus c1 is equal to 0. And let me take here BC. BC is equal to BC is equal to, I am taking here a2x plus b2y plus C2 is equal to 0. And next here CD. CD is equal to what means here CD and AB both are parallel to each other. When they are parallel, their x coefficient and y coefficient should be same and only constant is different. So here a1x plus b1y, these two are parallel. So here x coefficient and y coefficient I have written same and only constant we have write differently. So here I am writing d1 is equal to 0. And next here AD. AD is what here? AD is opposite to BC. So BC means here what we have to write here a2x plus b2y plus constant we have to write differently, that is I am writing d2 is equal to 0. Now what about the area of the parallelogram and how to find the area of the parallelogram when we have four sides, means four equations of the sides of the parallelogram. Okay, so now so here First let me give the formula, then we will go for the derivation. So here area is area of parallelogram is P1 P2 divided by sin theta. Okay, so here we will see this. Here what is P1 P2 and what is about theta? So here P1 and P2 are the perpendicular distance from the opposite sides. Okay, so here perpendicular distance means here for AB we can draw the perpendicular from the D. So here this is the perpendicular and the length of the perpendicular we can take as P1. P1 and P2 are the length of the perpendicular to the opposite sides. So here we can take this as D and DE is a P1. Next P2 means another perpendicular we have to draw. So but here we have to extend the side to draw the perpendicular from the opposite vertex. So let it be suppose F and this is the perpendicular and this length of the perpendicular we can take it as P2. And what about theta? Here theta is angle. Theta is angle between adjacent sides. Angle between adjacent sides of the parallelogram. Okay, so here AD and AB are the adjacent sides. So here you can take theta. Now here AD and BC are parallel to each other, and also here AB is transversal. So alternating the angles are equal. So hence this is theta means this is also theta. Okay. Now simply join BD to find the area of the parallelogram. Okay, so if you want to join AD with the dotted lines, then you will understand. So now area of, now here proof we are seeing area of parallelogram is equals to what? Here here we have joined B and D, both are the, of course now we can say BD is a diagonal. So area of the parallelogram is nothing but 2 times of the area of the triangle that ABD. Okay, so now 2 times of area of the triangle means here 1 by 2 base into height. Base is what? Here AB and height is what? Here P1. You can take it as first equation. Now we have to find out AB value in terms of P2. So in triangle ABF, here we have to find out AB and we know AF, that is equals to P2. Okay, so that means here theta, which is opposite side, is AF, and here it is 90 means here hypotenuse is AB. So hypotenuse we want and opposite we know. So opposite and also hypotenuse are involving in sine also cosecant. So here apply sine theta simply in this triangle. Sine theta is equals to opposite. Opposite means here AF. AF is equals to P2 divided by hypotenuse. Hypotenuse is AB. AB. So now you will write you will get AB value which is equals to P2 by sine theta. So here 2 will be cancelled and from 1 you can take it as 1 from 1 and 2. What we can write means here AB means here P2 by sine theta into P1. Okay, so here P1 P2 divided by sine theta. Okay, so this is the area of the parallelogram. Still here we can simplify this also. Okay, P1 P2 sine theta. So still we can simplify this. Still we can find the P1 value and also P2 value and also theta value. Okay, so that also we will derive and we will check it. So here what is P1? P1 is the perpendicular distance from the opposite vertices, sorry, opposite the side. So here P1, of course here AB and both CD both are parallel. So P1 is the distance between the parallel sides. When P1 is the distance between the parallel sides, what is the distance? Just now only we discussed. Okay, so here up to, I think up to this everyone it is clear. So from this point we will continue. So let me clean this and next we will see again. So here P1 P1 means here what? Here DC and also AB. So DC, CD and also AB. Now perpendicular distance means here what? Now modulus of C1 minus D1 divided by square root of what? A1 square plus B1 square. And similarly P2, what do you mean by P2? P2 means here again distance between the two parallel lines. When the distance between two parallel lines is nothing but here which are parallel means here these two are parallel. Okay, so that means your modulus of C2 minus D2 divided by square root of A2 square plus B2 square. Okay, so this is what P1 and also P2. And here we have sin theta also there. So sin theta also we can express in terms of the sides or the coefficient of the equations. Okay, so that also we will derive here. So here what we have means here tan theta is equal to m1 minus m2 divided by 1 plus m1 into m2. So this is the formula I have explained in my last video. Of course, this is nothing but the angle between the two straight lines. Angle between the two straight lines theta is equal to tan inverse of modulus of m1 minus m2 divided by 1 plus m1 into m2. Okay. So now here we will substitute what is m1 and also m2. So here m1 is nothing but here minus a1 by b1 minus m2 means your second equation minus a2 by b2 divided by 1 plus m1 m2. Okay, so now here take the minus common, and when you are simplifying here LCM is b1 b2 and here a1 b2 minus a2 b1. Okay, after taking minus common you will get it. After taking minus common and modulus, because of the modulus, here you will get a1 b2 minus a2 b1 divided by LCM is b1 b2. And here even the denominator of b1 b2 is LCM, and after doing this here you will get a1 a2 plus b1 b2. Okay, so now b1 b2 will get cancelled. So hence what we will get means here a1 b2 minus a2 b1 divided by a1 a2 plus b1 b2. Okay, so this is the value of tan theta. But what we have means we have sin theta. So sin theta means we have to find sin theta here. We have tan theta now. This is the value of tan theta. But we want sin theta value, and after the rule we can substitute this P1 P2 sin theta value to get the area of the parallelogram. Okay, so we will see that also. So here tan theta means what? Here opposite by adjacent. So here a right triangle, okay, opposite, suppose here theta is here and opposite is what here? A1 by, let me write it. Okay, so now I am taking theta here and opposite means here this side here A1 B2 minus A2 B1, and adjacent means this side that is equals to A1 A2 plus B1 B2. But sin theta means here opposite divided by hypotenuse. So hypotenuse we have to find out. So hypotenuse means here what? Let it be suppose here ABC and angle B is 90. So here AC square means here AC square is equals to what here? A1 B2 minus A2 B1 whole square plus A1 A2 plus B1 B2 whole square. So just expand here A1 square B1 B2 square plus A2 square B1 square minus 2 A1 A2 B1 B2 plus again same here A1 square A2 square plus B1 square B2 square plus 2 A1 A2 B1 B2. Okay, and these two terms will get cancelled, and hence here in these two terms when you are taking A1 square common you will get A2 square plus B2 square, and in these two terms here when you are taking B1 square common then you will get A2 square plus B2 square common. So again here A2 square plus B2 square when you are taking common then you will get A1 square plus B1 square. So this is the AC square value. So here AC is equals to what means here? Square root of A1 square plus B1 square into A2 square plus B2 square. Okay, so this is the AC value, means hypotenuse. So here these are the values of P1 P2 because that we want, and even tan theta value we want. because we want to know opposite side. Better here, there I have written one, so fine. So here area of parallelogram is equals to what? B1 B2 by sin theta. So now substitute all the values. Here P1 means your modulus of C1 minus D1 divided by square root of A1 square plus B1 square into P2 means your modulus of C2 minus D2 divided by square root of A2 square plus B2 square divided by sin theta. So sin theta means here what? Of course 1 by sin theta. 1 by sin theta means here what will happen here? Cosecant theta. Cosecant theta means here what? Here hypotenuse. Hypotenuse is what means here? Square root of A1 square plus B1 square into A2 square plus B2 square divided by opposite. Opposite is what? Here modulus of A1 B2 minus A2 B1. So here A1 B1 whole square and this terms will get cancelled. Hence you will get mod C1 minus D1 into C2 minus D2 divided by modulus of A1 B2 minus A2 B1. Okay. So this is the final formula. Okay. When you have parallelogram and with 4 sides and 4 equations, how to find the area of the parallelogram means modulus of C1 minus D1 into modulus of C2 minus D2 divided by modulus of A1 B2 minus A2 B1. Of course, in the denominator here we can write in the form of determinant. So determinant, how can we write means here? Of course, let me write here. The numerator there is no change here, but the denominator how can we write means here? A1 A2 B1 B2 modulus. Okay, in place of this we can write this. So when you apply the modulus, it means you will get what here? A1 B2 minus A2 B1. Okay, so this you can use to remember the formula easily. Okay, so this is also lengthy video only. So thank you for watching. Thank you all.